Good evening, everyone. You are welcome. There's still someone that has not joined yet, but I think we just have to just go on with the class. So basically, yesterday we encountered some technical issues that did not allow us to, number one, record the session yesterday. Then number two, um, it we were unable to finish the time set. We had set 2 hours, but we couldn't do up to 2 hours. We had some glitch, but it's been resolved now. So apologies for that. So I just want to recap some of the things that we said yesterday, so that at least it will be recorded, so that I can now finish up with the first module today. By I mean, hopefully. So basically, we talked yesterday about elements of information security, and I discussed about confidentiality, integrity, availability, authenticity, non-repudiation. We said confidentiality is a data that is only that's when data is only accessible to the authorized user. So only the person that is authorized has access to the data, and that is confidentiality. So very very key. Just like the example I gave yesterday, that there was a particular optician's office that was hacked, and all the patient data, including their nude photos, were leaked online. Of course, the confidentiality has been breached, because when those people went into those offices, they never uh, had it even in their mind that their data will be leaked. If it had even crossed them, and maybe they would not have visited that optician's office. So that's very important. It's number one element of information security. The data has to be only to the authorized user, just like you're all joining it now via or using your Gmail. Now, if somebody else is able to log into your Gmail and do all manner of things, then there's no longer any confidential. Then integrity, that's the data has not been changed. I talked about yesterday. Integrity means the data or resource has not been changed. There's no improper or unauthorized change to the data. So what you see on one end is what you see on the other end. So it has not been tampered with. The availability means the data or resource is available to the authorized users. If you have, for instance, you want to log into your Gmail, and you put in the sign I mean the login ID and also the password, and you're unable to log in, then that means that system or that data or your email is not available. So availability is very very crucial in information security. So because there's no point if you are safeguarding data or resources or system or devices or network, and it's not available to the authorized users. There's no point. So the essence of any system or any setup, network, or data or resources or system information system, is for it to be accessible, to be available. So if it's not available, then it is not meeting up with its use. Then we talk about authenticity. Authenticity, that is genuine. That means that the document or the data is genuine. It's not fake. The non-repudiation. Non-repudiation is an element of information security that ensures that both the sender and the receiver of a message cannot deny that the sender cannot deny sending it, the receiver cannot deny receiving it. So very very key, because we need to track how data is transferred from one person to the other, and to make sure that we can track that this was sent by someone and was received by the other person. Now we talk about motive, and goals, objectives, and information, and objectives of information security attack. So there has to be a motive. There has to be something motivating the attacker. He has to have a goal in mind. He has to have something that, oh, once I breach this particular network, once I attack this network, this is what I will gain. This is what I will gain. If there is no gain there, then why go through all the trouble? So there has to be motive, and we'll talk about the different motives: disrupting business continuity, stealing information and manipulating data, creating fear and chaos by disrupting critical infrastructures, causing financial loss to the target, propagating religious or political beliefs, achieving a state's military objectives, damaging the reputation of the target, taking revenge, demanding ransom. I talked so much about this yesterday. We talk about the different types of attacks. We have different classification of attacks. We have passive attacks. So there's no tampering with the data, and it's just monitoring, pure monitoring, where we have sniffing and eavesdropping. Somebody is just sniffing or eavesdropping on a communication that is ongoing, so it doesn't tamper with the flow of packet from maybe one end to the other, one device or one user to the other. It's just listening and monitoring the flow of the traffic, monitoring to see, okay, what is this person moving, what is the content of the packet moving from one end to the other. Now, we'll be talking a lot using the open system interconnect. That is purely networking. Purely networking. You may need to read up on networking. Very, very key. Now we'll talk about the OSI model, and we'll talk about the TCP IP model. Now, in the OSI model, open system interconnect, we have 7 layers. We have the application, we have the presentation, we have the session, we have the transport, we have the network, we have the data link, and we have the physical layer. So um, at the level of the uh, physical layer, the data is referred to as bits. When it moves to the network layer, it's referred to as sorry. When it moves to the uh, data link layer, is referred to as frames. When it moves to the network, is referred to as packets. When it moves to the transport layer, is referred to as segments. So we'll talk more on that as time goes on. So I just wanted you to have that at the back of your mind. You can take note of that and read more on that. So we have active attacks. Active attacks tamper with the data in transit or disrupt the communication. So this, they tamper with the data in transit, or they disrupt communication between the systems. So example includes denial of service. Denial of service is when uh, just like we mentioned under the elements of information security. One of the elements of information security is availability. Now, when denial of service attacks are carried out, the attack is meant to stop authorized users from being able to gain access to the data or the resource that they're supposed to gain access to. For instance, in Nigeria, here we have people filling or accessing JAMB, that's for their tertiary education. Now, when they try to access it at a time, I think there was a time like that, they couldn't access it. Whether you are a legitimate or illegitimate user, they couldn't access there was too much traffic on the site. So now what attackers do is that they pump so much traffic, so much packets into a particular website, and with that, it may not even be a website, it may be a web server or anything, and disallowing people that are supposed to be legitimate users from accessing that thing becomes unavailable. Like the example I usually give in my classes, when you have like a 6 lane or 3 lane uh, road, it's a 3 lane or 6 lane road, and now let's say 3 lane road, for instance, 4 cars are now trying to pass side by side on that 3 lane road. What happens is that uh, none of the cars will be able to move through. They will can't move through because it was made for 3 cars to pass at once. So that's the simple analogy I can give for denial of service. So we'll talk more on that later. Then we have man in the middle. Instead of the um, data moving from one device to the other, it moves through the attacker. Then to, for instance, if a victim is trying to access a web page, he types in the IP address of the web page, or rather, he types in the domain name of the web page in his web browser. So the DNS takes over, converts that IP, I mean that domain name into an IP address, and he is able to access the web page. So in man in the middle, what it does is that it does what we call IP spoofing. So IP spoofing is they now redirect the traffic from the victim. Instead of going straight to the web server, it passes through him. So he's able to access everything. When the person is clicking and sending passwords, login details, he's able to see them, especially if they are unencrypted. So then we have session hijacking. You can hijack the session, and also SQL injection. Then closing attacks, this is when an attacker is in close physical proximity with the target system or network in order to gather, modify, or disrupt access. So, example includes social. Hello. Sorry, can you mute your mic? Thank you. Or do you have a question, please?
Sorry, it was a mistake.
Okay. No problem. All right, let's go on. So now, closing attacks, you have example like social engineering, such as eavesdropping, shoulder surfing, and dumpster diving. Like I explained yesterday, eavesdropping is just listening to um, I mean, it may be maybe tap wiretapping a particular mobile device, listening. That can be used. Then shoulder surfing is just peering over the shoulder of someone to see the maybe the person is entering his pin. It happens, or maybe it used to be commonplace then, especially in Nigeria, at ATMs, where somebody could just be peering to see. But now I think everybody is wiser for it. So everybody shields the pin when entering it. So shoulder surfing could take place, or even in an office where somebody is accessing some uh, uh, details or some resource that requires login details. So somebody else could be doing shoulder surfing to see what the person said, or even just you are beside somebody trying to access your mobile device. The person could be shoulder surfing and trying to say, okay, what is your pin and all that. So those are common things. So dumpster diving, like I said yesterday, going through the garbage. Now, many companies now use shredders. So any document you may see in their garbage may be useless because they have shredded it. But if there are companies that are not using shredder, then you can easily piece together information or data from their garbage. So that's a closing attack. Then we have insider attacks. This is one of the most difficult attack to mitigate. Why? Because a person that is an insider, you can't really guard, or most of our countermeasures are basically against outsiders. But when somebody is on the inside, it becomes an issue. So they use privileged access to violate rules or intentionally cause a threat to organizations' information. So if such people, they may have been sent by competitors. They may have been sent by competitors to spy on a particular organization. So a computer can even sponsor a person and make sure the person gets employed just because he wants to infiltrate and get a particular information. So this include theft of physical devices, planting keyloggers. I told us about keyloggers yesterday. We'll talk more about those later. Backdoors and malware. Then distribution attack. This happens when they tamper with hardware or software prior to installation. So why is distribution attack is that once it's done at the source or prior to distribution, it goes wide. It goes wide because at the point of uh, the source where that's where people get it. And once you can tamper with software or hardware at its source, then by the time people are getting it's already tampered with, and they will be getting um, uh, maybe malware. Software would have turned into a malware because it will have malicious things that it can do on one system. Yes. Okay, we talked about this information where we have warfare, we have defensive information warfare. You defend all strategies that are supposed to defend against attacks on ICT assets. We have prevention, deterrence, alerts, we have detection, we have emergency preparedness and response. Under alerts, that's where you have what's it called, antivirus. Antivirus gives you alerts and it's based on a signature. So you have to make sure that you are updating your antivirus signatures regularly. You have to do that regularly so that um, it can give you the necessary shield against viruses. So, but if you are not updating it regular, definitely as new viruses come in, then your antivirus will be useless against them. So then we have offensive, we have web application attacks, web server attacks, malware attacks, man-in-the-middle attacks, and system hacking. All those things will still deal with much more details as we go along. We have the CH hacking methodology. Like I said before, there are different hacking methodologies, but CEH hacking methodology starts with footprinting, and footprinting is basically trying to know the terrain, so to speak, in quote, that you are attacking. If you if you are conversant with the military, you will know that before they go into a particular place, they have these ISR planes, reconnaissance planes, that aircraft, let me put it that way, that go and scan the entire place to know, okay, this is where the enemy is gathering. They will have the map and all that. So that map is what the map they generate is what the foot soldiers will use, or they can even give those details to the air force to bombard those places. So footprint is just like that. You want to know, okay, this place I'm going, what is the network topology that they have? Okay, well, what are they using? Are they using switch? Are they using routers? Okay, now they are using switch. How many devices? Okay, okay, what is the network uh, configuration? Okay, what's the IP address range? Okay, what devices are on, what hosts are alive? Those are things you are trying to search out on footprinting to know what is the network topology. Then you go to scanning. Scanning allows you to know, it also helps you to know the hosts that are alive, the hosts that are working, the devices that are on. Then you will now know on those devices what are the ports that are open on those devices. Now, in communication, we have what we call, that's OSI model. We have the under transport, we have TCP, and we have UDP. Now, TCP, transmission control protocol, it deals with connection oriented in the sense that it does the three-way handshake, sends SYN and receives SYN plus ACK, then now replies with ACK for the connection to be established. Until that is done, it will not send any message. While we have the user datagram protocol, which doesn't bother about establishing any connection, it just sends, and those are for maybe video communication, voice over internet protocol, and all that. So, but for TCP and UDP also, they have ports that they use, different services on systems use different ports. Now, for instance, we have our usual web applications. We have the HTTP. When you are browsing, you are using that protocol. You are using hyper text transfer protocol. When you are doing email, you are using simple mail transfer protocol, which is port 25. HTTP is port 80. Now, secure HTTP, which HTTPS, which we are all familiar. When you see that padlock on that particular website, you know that yes, this one is secure. That one is port 443. So these are ports that you need to familiarize yourself with to know. Okay, DNS, okay, is 53, SSH 22, Telnet 23, FTP 21, and so on and so forth. So there are so many. So all those ports, the scanning allows you to identify which ports are open, what services are running on those ports. So it is those that will now help you to know, okay, this. By then also more very important, the operating system. The operating system, to you get to know what is the operating system that is running. So if you know the operating system, you can also know the version of the operating system. So that is what you get during scan. Then on the enumeration, you get to know the users. Who are the users on the I mean on in this network? Where the users, and mind you, the reason why the attacker is looking for the user is not just because he likes them, but he wants to know the administrator, the users that have administrator privileges, because it's those that have administrator privileges that he can use their account to install and uninstall and do many things within that network. So that's what enumeration, the vulnerability analysis, you try to do vulnerability analysis to know what are the vulnerabilities or the loopholes in the system. Then you go to system hacking. Sorry, I'm rushing. I've already dealt with this yesterday, but I just wanted it to be in the recording so that we can have access to it later. Thank you. So now, system hacking. Um, you gain access under system hacking. That's the first thing for you to do under system hacking, and you do this by cracking passwords. Where we can do hybrid, you can do brute forcing. Brute forcing is entering random passwords, entering random password and hoping that one we enter. Very very demanding, but we have tools that can do that. We'll talk more about that when we get to that aspect. Then we can do brute forcing or dictionary attacks. Dictionary attack, you enter different dictionary words to see which of them will 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 enter, so to speak. Then we have vulnerability exploitation, exploit the vulnerability that is existing within that system. Then the next thing after gaining access is to escalate privilege. Like I said, the attacker wants to be able to um, install and uninstall. He wants to be able to do and undo, so to speak. And without escalating privilege, without having administrator privilege, he can't do that. You want to be able to maintain access. To be able to maintain access, he needs to install some backdoors, some trojans, so that and that's where we come to executing applications. So then he wants to some attackers will install what we call remote access trojan, and this will allow them to be able to control the that particular computer from anywhere they are. So the client version of the RAT, the remote access trojan, will be on that computer, while the server version will be on a command and control center. So those devices, they are now called what we call botnets. So they essentially carry out the command of the attacker from where he is. They can be used to attack uh, web servers or other networks or whatever, to bring it down. In the process called distributed denial of service. So we'll still talk more about that later. Then you can hide files, because if you don't hide files and somebody that is going through, the administrator or the cybersecurity analyst is going through the system and he sees those files, he will know that there's something has gone wrong somewhere. So he will now try to eliminate all those files and see to get rid of the attacker and his footprint on that network. So they need to hide the files. Then they clear logs, because like I said yesterday, everything that is done on a system is recorded. If you go to the security events viewer, you will see it. If you are using a Windows system, you will see that everything is logged as you log in As you do this, you open this application, close that application, everything you do. So the logs needs to be clear, and so that they can easily cover their tracks. So we also talked about cyber kill chain methodology. We talk about reconnaissance, which is essentially the same thing like as footprinting. Then once you do the reconnaissance, you gather data and probe for the weak points. Then you now look for the payloads that will be able to exploit those weak points. Then you now work on your mode of delivery. How are you going to deliver the payload? That the payload that will exploit that vulnerability you found. So you can do it using email. I talked yesterday about phishing. I talked about spear phishing. Spear phishing is just phishing that involves, for instance, if um, an attacker was able to get emails of a particular organization, let's say staff of a bank, is able to get their emails now, and he wants to gain access to the network of the bank. So what he does is that he can do spear phishing and send phishing emails to those the staff of the bank. Now, any of the staff of the bank who is ignorant enough to click on the link or download the attachment to those phishing email now becomes the person through whom the payload is delivered into that network. And once he's able to access that network, then he will be able to go around from the one system to the other and all that. So exploitation is you exploit a vulnerability by executing your, remember it's been delivered, then you go to installation, then you go to command and control. So like I said, if the attacker is able to install that malware, it allows him to be able to control the system remotely. So then he can now do perform actions to achieve his objectives and goals. Okay, we talked yesterday about tactics, techniques, and procedures. Tactics are guidelines that describe the way an attacker uh, performs the attack from beginning to the end. So that's tactics. How does he perform the attack from beginning to the end? Techniques are the technical methods used by an attacker to achieve intermediate results. Then procedures are an organizational approaches that actors follow. So, like I said, many things that you see happening is not the work of one single individual. Many of the attacks that you see, especially the large scale attacks, even the minor ones, there are people that are well organized. They are uh, part of group syndicates. You understand? So they are not. It's not just an individual that is that's doing that. So tactics, threats, tactics, techniques, and procedures. Tactics are guidelines. Techniques are technical methods that are used. Then procedures are the organizational approach. Okay, we talked about the diamond model of intrusion analysis yesterday. So when an intrusion takes place, how will the uh, cybersecurity analyst or the security or organization, how or the cybersecurity um, analysts within the organization, how will they break down the intrusion that has occurred? How will they analyze it? How will they look at it and say, okay, what happened here? So this is a model of doing that. So it offers a framework. Diamond model, it offers a framework for identifying the cluster of events that are correlated on any of the systems in an organization. It can control the vital atomic element occurring in any intrusion activity, which is referred to as a diamond event. So using this model, efficient mitigation approaches can be developed and analytic efficiency can be increased. So we have the adversary. I talked about this yesterday again. We have the adversary, that's the attacker. We talk about the infrastructure he used. That's the tools he used, then the capability is the skill, then the victim who was exploited. The adversary uses the infrastructure to connect to a victim, and he develops the capability to exploit the victim. So, uh, capability is the strategies or the how. How was the attack carried out? Infrastructure is what the adversary used. What did he use to um, to reach the victim? That could be through phishing. It could be through drive-by download and all that. So many means of attack. So yesterday we also talked about what is hacking. It's just basically exploiting system vulnerabilities and compromising security controls to gain unauthorized or inappropriate access to a system's resources. So it's exploiting system vulnerabilities and compromising security controls. So when, like I explained yesterday, vulnerability is a loophole or a weakness in a system. It's a loophole or a weakness. So if that loophole is not dealt with, is not taken care of, there is no perfect system anywhere. The operating systems that we are using, they all have their vulnerabilities. The apps, the applications, the software that we install on our phones, on our laptops, on our computers, all have vulnerability, and that is why from time to time, hot fixes and patches are usually released in order to take care of these vulnerabilities. So it now behoves on you as a cybersecurity analyst, as an administrator, to make sure that you are up to date on these offices and patches. That's why from time to time your app will always pop up that you need to do something, you need to update. And in updating, you are trying to cover the loophole, the vulnerability, or the weakness that is being exploited by attackers. So hacking is exploiting system vulnerabilities and compromising security controls to gain unauthorized or inappropriate access to a system's resource. You exploit the vulnerabilities and you compromise security controls. It involves modifying system or application features to achieve a goal outside of the creator's original purpose. It can be used to steal and redistribute property, leading to business loss. So that's one very key thing when it comes to hacking. It can lead to business loss, it can lead to loss of reputation. Because, for instance, I keep going back to this story of the optician's office. These people went to the optician's office to be attended to, and now all their data is all over the internet. Of course, that you can't expect people to keep flocking there. They will definitely not go there again. Or that may close that business. So it can lead to, of course, it can lead to business loss. So it may close that business. So those are things that do happen. Now, we talked about a hacker. He has excellent computer skills. Some hackers, it is just a hobby. Then some hackers are just purely doing research, and some just to probe to see, okay, how far can I go, and some to do illegal things. Now, we have hacker classes. We talked about this yesterday. Black hats. There are people that attack. They do the hackers that are that breach system security. Their intention is malicious or disruptive, and they are also known as crackers. Then we have white hats. These white hats are purely for defensive purposes. They are usually employed by organizations. Of course, black hats are not employed. They are people that force their way in, so to speak. They attack the organization. But white hat hackers are purely for defensive purposes. They usually have the permission of the organization to test their network security, Then we have gray hats. Whenever it's whatever suits them, or let me say, who pays the highest price is who they will go with. They can decide to be offensive, which is black hat, and they can decide to be defensive, which is white hat. So I believe they go for the highest payer. So those are gray hats. Then we have suicide hackers. This bring down critical infrastructure for a cause. So they are suicide hackers, just like suicide bombers. They are suicide hackers. They don't care if they are going to jail. They don't even bother to cover their tracks or do anything. Normal hacker will want to make sure that it's not caught. But these ones, they are ready. They are willing to be caught, or they are just interested in let them bring down critical infrastructure for a reason. Then we have script kiddies. These are people that use tools, scripts that are developed by real hackers. Most of us fall into this. It's not really easy to build scripts. Very few people can really do that. Build tools. So many of us use tools that have been built by others. Then we have cyber terrorists. This they have a particular belief, and they try to uh, act based on that belief. So you can have people, for instance, that take sides, especially concerning the war that is going on, so to speak, in between Israel and Palestine. So some people can decide they are cyber terrorists and start attacking um, Israel in order to, in order to bring down their critical infrastructure. Everything is being controlled by computers now. Like I said, there was a projection that the next world war that will be fought to be using computers. It will be fought using computers. So that's why we have state-sponsored hackers. So, like even Nigeria Army has its own cyber warfare units now. They have a department like that. So everybody's getting ready, trying to train his people to make sure they are able to defend. So state-sponsored hackers, individuals employed by government to penetrate and gain top secret information from and do damage to the information systems of other governments. So remember, uh, was it? I can't remember how many years ago was that. About getting to about 8 years now, maybe 6, 7, 8 years now, that Russia was accused of meddling with the electoral system in the United States. So those are state-sponsored hackers. Then we have activists. They have a political agenda that they are promoting. They have a cause. So and they can easily do this. They do this by hacking or defacing or disabling websites. Niger cyber activists is an example of that. They did it to power holding company then, and they wrote on the power holding company, the font power holding company. They wrote on their website, "Let there be light." So that's an agenda. We have hacker teams, a consortium of skilled hackers. They have their own resources. They work together for researching the state of the art technologies. We have hacker teams, and we have industrial spies. They perform corporate espionage. Insiders, any trusted person who has access. We'll talk about this insider attack. So this one, they use the fact that they're already in the system, they have access to particular things. And one thing, I believe Mr. Tayo will agree with me on this, that one of the ways to mitigate against insider attack is through rotation and separation of duties. So essentially, when somebody is in a particular department, um he's not kept there for long. You move him to another place, move into, and that's one of the mitigation measures that you use. Then we have separation of roles. If you are not, I mean, handling a particular assignment, the resources for handling that assignment is not given to you. So you only have the resources that are needed for you to handle your assignment in that organization part time. So that's a very good way to mitigate insider attacks. Then we have criminal syndicates. This group of individuals that are involved in organized, planned, and prolonged criminal activities. they illegally embezzle money by performing sophisticated type cyber attacks. So we have criminal syndicates, we have organized attackers who are hackers, sorry. They are miscreants or hardened criminals who use rented devices or botnets to perform various cyber attacks to pilfer money. So those are organized hackers are mostly the ones that are responsible for the ransomware we're experiencing very rampant when you see, I mean, experience now. Ransomware, they hold on to your resources and they tell you that for you to unlock those resources or that network, you need to pay, mostly crypto. So, and if you don't pay, you will not be able to access it. But like I said yesterday, the best way is not to pay. All right. So, what is ethical hacking? What is ethical hacking? Ethical hacking involves the use of hacking tools, tricks, and techniques to identify vulnerabilities. So you use the tools, we use the techniques to identify vulnerabilities and to ensure system security. So we know the hacking tools that are out there. We know the tools that hackers use. So we use these same tools because when a hacker is attacking your system, your network, he's not playing, is not going to be missing punches or punching the air. He will be using the best tools available. So these same tools is what an ethical hacker uses to try to identify vulnerabilities and ensure system security. So once he identifies, he prepares a report. He prepares a report and gives to the organization to say, okay, these are the vulnerabilities I've identified in your system. Can you do something about it? Can you rectify this and all that? So it's not left for the company to know, okay, these things, can we work on it? And there are many issues that come up. Sometimes you can have maybe some of these things may cost money, and the organization will be looking at, would they start weighing the risk? And that's when risk management comes into place. That, okay, can we manage this risk? Is it possible for us to manage this risk at all? Is it possible, or is something that if this risk, if is exploited by the threat actor, can it cause damage? What kind of damage can it cause to us? So those are risk management questions they will need to ask themselves. So if there are things that they can accept, if there are risks they can accept, if there are risks they can manage, then they will do that. Now, ethical hacking focuses on simulating the techniques used by attackers to verify the existence of exploitable vulnerabilities. So you want to know, do we have vulnerabilities? The system has been set up. You have set up your routers, you have set up your switches, you have set up your intrusion detection system, you have set up your firewall, you have set up your intrusion prevention system, you have set up your honeypot, you have set up your other devices and every other thing within the network. You have put up your software, you are using maybe Microsoft this in IIS, you are using Linux, you are using this, you are using that. Are there vulnerabilities? So we want to verify as an ethical hacker, is there vulnerability? Did somebody forget to change the default password while setting up a particular device? As funny as it may sound, it's something that occurs regularly. Somebody may have forgotten to change the password. A lot of work is done and all that, they may have forgotten, and that's a vulnerability staring them in the face. Then ethical hackers perform security assessment for the organ, of course, with their permission. So there's a written permission, there's a contract that is signed. This is what we have to look for, and they look for it. If they see, if they don't see, well and go. So why is it necessary? So I think this is where we stopped yesterday. Please indicate that you are following me and you are flowing with the course so far. Please let me hear from you.
We are.
Okay, awesome. Why is ethical hacking necessary? It's You need to beat a hacker, you need to think like one. It's just an example that I give. You if you have experience, especially in managing security, physical security, by the time you come to a particular building and you are told to assess the security of the building, now talking about physical security, which is actually part of information security, as it were, because many of the devices, not all devices are hardware. We also have, not all devices are software. We also have hardware that need to be protected and all that. So when you are talking about a person performing a security assessment, if he comes based on his experience, he will tell you, you made a mistake here, you should have done this here, this thing not to be here. Maybe you living abroad in the US and all, you may not be able to identify, but in Nigeria you have, there are things you don't place in your compound. Something like maybe a pole or ladder or things that can easily be used by a thief or a burglar to access your compound or to break through or break in rather into the place. So those are things that we refer to. So you are a when you are trying to be an I mean when you're an ethical hacker, you have to think like a hacker and say, okay, if a hacker comes here, what are the things that he will be looking for? What are the things he will exploit? Just like a burglar or a thief will be looking at weaknesses. In Nigeria here, one of the things they do is that they will come be looking, especially the windows and the doors. Is it easy for them to be able to break in through the doors, the windows? Another thing they do is to go through the roof, the what's it called, the ceiling outside to see if they can break in. Now that many people are blocking that, they are blocking it by putting blocks up so that even if you come through the ceiling outside, you can't go into the building. So now they look at the burglar. Is it strong enough? Can they shake it? Can they break it from all those manner? So that's the same way a hacker will also think and look at um, what is the setup. Okay, what are the vulnerabilities? What is the network topology and all that? So to beat a hacker, you need to think like one. Ethical hacking is necessary as it allows for counterattacks against malicious hackers through anticipating the methods used to break in to the system. So you anticipate and you say, okay, this is the way he may come in, and you try to anticipate and block that route, take care of that vulnerability, block that loophole. To reasons why organizations recruit ethical hackers: to prevent hackers from gaining access to the organization's information system, of course, to uncover vulnerability. So it's better if you, as the owner, are able to see the loopholes first and take care of it, and an attacker now takes advantage of that. So it's better. That's why ethical hacking is necessary, for the person to identify the vulnerabilities before an attacker sees them. Just like what we say in CH, you say hackers are here. Where are you? So hackers are everywhere. They're always trying to exploit the system. So we need to be on top of our game. Okay, the third reason: to analyze and strengthen an organization's security posture, including policies. Just like one of the key policies, I think that a simple one, but nonetheless very key. Password use. You can't use a particular password for more than 30 days. Very key, very simple as possible policy, but difficult for some people to abide by. And you know that many a times many of these passwords are leaked. They are leaked. Even was it last year that LinkedIn was breached, was attacked, and they were able to get login details of millions of users. So, and incidentally, many users use that same email on other services. So you can see the risk that it poses. So very, very important. So it helps and to strengthen, to analyze and strengthen an organization's security posture. What is the posture? How do you handle security incidents and all that? The network protection infrastructure and end user practice is very key. Do we allow tailgating? Tailgating is you have access to a particular maybe a server room or a building, let's even say a building, and that requires you to use maybe a card or enter a pin for you to access the building. Now, um, somebody now comes in and say he forgot his card at home or something, and you allow the person to go in with you. So those are things that you should not be done because you could be allowing an attacker to gain access even to the building. So those are things. Then when we talk about eavesdropping or shoulder surfing, those are things that once people are aware, they are aware of the uh, downsides of those kind of things, then they can be able to um, prevent or to be more aware about those and to avoid such things happening to them. Then, number four, to provide adequate preventive measures in order to avoid security breaches to help safeguard customer data. That's uh, reasons why we recruit ethical hackers to enhance security awareness at all levels in a business. To enhance security awareness at all levels in a business. So very very important. Security awareness is very very key. People, they are the ignorance, like we always say in ethical hacking that security is only as good as its weakest link, and the weakest link is the human being. That is the weakest link. So that is the person that will not use that will not change the password. That is the person that will allow somebody to shoot herself. That is the person that will do one thing or other, or that will click on a link. That's the person that will click on a phishing email and all that. So you can put up all manner of security practices and measures, but if there is no awareness, then people can be ignorant. They can do things ignorantly, and they make all those things to be of no use. Okay, sorry. Can we just take break for 2 minutes? I'll be right back. Thank you. Okay. Yes, I'm back. I hope you can hear me.
Yes, we can hear you.
Okay, awesome. Let me just fire on. Okay. Yeah. So why is ethical hacking necessary? We have talked about, we are trying to get into the head of hackers to see, okay, what are they looking for when they are attacking a system? We are trying to see, okay, what is the thing that the vulnerability they will take advantage of? What is the security posture? Then the what is the question that the ethical hacker is trying to answer? It wants to know what can an intruder see on the target system. So that's reconnaissance. What can it see? That's footprinting. Footprinting and reconnaissance are used interchangeably. So what can it see on the target system when he's scanning the target system? Can it see what ports can it see that are open? What services can it see that is running? What are the vulnerabilities of these ports and these services? What can be achieved using these things? So that's what the first question that an attacker, ethical hacker tries to answer. Then it tries to see what can an intruder do with the information that he got in this reconnaissance and scanning phase. Can he use it to gain access and maintain access? Then does anyone, number three question, does anyone at the target organization notice the intruder's attempt or successes? That's reconnaissance. When people, when there's a scanning going on, is because when you are scanning, of course, it will be sending. You are sending a lot of things. For instance, scanning, you can be using ICMP, Internet Control Messaging Protocol, and using ping, ping. You ping to see if you ICMP echo request to see if there will be a response. Then you know, okay, it's alive. So all those things. There's a network analyzer. You can use maybe TCP view. You can be seeing, okay, somebody is doing. So is there somebody monitoring to see if somebody is sending requests, is scanning, is checking our system? Is there anybody noticing that? So then that's the reconnaissance and the covering tracks. Is the attacker able to cover his tracks? Is anybody monitoring the security logs, checking to see the security viewer? What are the things going on? So that those are things that the attacker, ethical hacker, tries to see. Then number four, are all components of the information system adequately protected? Are they updated and patched? That's like I mentioned that earlier on. So updates and patches, opt fixes, and all that are to block loopholes. Number five, how much time, effort, and money are required to obtain adequate protection for the system? Number six, are the information security measures in compliance with the legal and industrial? So there's a standard. There's a standard. Are they meeting up? We have standards. We'll talk about that. Then, what are the scope and limitation of ethical hacking? It's a crucial component of risk assessment, auditing, counter fraud, and information system security best practice. It is used to identify risks and highlight remedial action. So it's not just seeing the vulnerability, seeing things that the that particular organization is open to, their network, their system, but you highlight remedial actions. What should they do? That's part of the report that will be generated. So it reduces ICT costs. So prevention, they say, is better than cure. So it reduces ICT cost by resolving vulnerability. So what are the limitations? So the limitation is that unless uh, the particular organization knows what they are looking for, they may not be able to gain much from that experience. If there's something they are really targeting to say, okay, we want to know this. But if you just give somebody, in the end, it may just be a waste of time and effort. So the ethical hacker can only help the organization to better understand the security system. So it's left for the organization to do what is necessary based on the report that will be presented by um, the ethical hacker. So, what are the skills? You should have an in-depth knowledge, technical skills of a ethical hacker. You should have an in-depth knowledge of major operating environments such as Windows, Unix, Linux, and Macintosh. And I want to say here that this is a progressive stuff. It's not a one-day affair. So at least you can have a working knowledge of these platforms. We have Windows, whatever is common in your operating environment. You need to have a working knowledge. You can, there are materials and resources for this to be able to know and have more understanding of these environments. Then in-depth knowledge of networking concepts, like I said, networking very crucial, technologies and related hardware and software. So very good uh, knowledge of that. Then a computer expert that is adept at technical domains. So it's part of what we are doing, trying to build up our knowledge and understanding of different technical domains. So that's part of what we are doing in this course. So um knowledgeable about security areas and related issues, high technical knowledge for launching sophisticated attacks. Then the ability, non-technical skills, the ability to learn and adopt new technologies quickly, strong work ethics and good problem solving and communication skills, committed to organization security policies, awareness of local standards and laws. Information assurance. This is the assurance that the integrity, which are the, remember our five elements of information security: confidentiality, integrity, availability, authenticity, and non-reputation. So information assurance is the assurance that the integrity, availability, confidentiality, and authenticity of information and information system is protected during the usage, processing, storage, and transmission of information. So some of the processes that help in achieving this include developing local policy, process, and guidance, designing network and user authentication strategies, identifying network vulnerabilities and threats, identifying problem and resource requirements. Sorry, it's like somebody wanted to say something. Okay, I'll just go ahead then. So creating plans for identified resource requirements, applying appropriate information assurance controls, performing certification and accreditation, provide information assurance training. So all these are very key when it comes to um, information assurance. Now let's talk about what is risk. What is risk? I talked about risk management uh, some minutes ago. What is risk? So risk is the degree of uncertainty or expectation that an adverse event may cause damage to the system. Is It refers to the degree of uncertainty or expectation that an adverse event may cause damage to the system. They are categorized into different levels according to their estimated impact. So a risk matrix is used to scale risk by considering the probability, likelihood, and consequence or impact. So we have risk as risk. What is um, uh, the risk or the degree of uncertainty or expectation that an advancement may cause damage to uh, the system? So that's essentially what risk is all about. What's the probability, so to speak, that if this thing occurs, if this attack occurs, it will cause a damage to the system, and what kind of damage are we looking at? So then we look at what is risk impact. Risk impact. So we have different levels of risk. We have extreme or high risk. What action should be taken? Immediate measures should be taken to combat the risk, identify and impose controls to reduce risk to reasonable. It's possible, it's not possible to what's the word, to eliminate risk. You can manage it. It's essentially is you can mitigate. That's it. You mitigate, you manage it. But for you to eliminate it is almost impossible. So you manage to reasonable low level. So medium risk level. No urgent action is required. You implement controls as soon as possible to reduce risk to a reasonable low level. Then low risk level, you take preventive steps to mitigate the effects of risk. So you have the extreme or high, you need to take immediate measures. Medium, no urgent action is required. Low, you take preventive steps to mitigate it. So we have the different types of we have an example of a risk matrix. So it depends on the organization. The organization will create different risk matrix different depending on the organization. Now we have probability. The probability is in percentage, the likelihood. Then you can see here we have very high probability. I believe you can see my cursor pointing. We have insignificant, that's it's low. When we have that's other consequences. It can be minor, medium, moderate, high, major, extreme, severe, extreme. So those are the consequences of the risk. Now, like I said before, risk management is what we do. So the process, so you can't eliminate risk. What you can do is to manage it. So the risk management is the process of reducing and maintaining risk at an acceptable level by means of a well-defined and actively employed security program. So you manage risk, you just reduce and maintain it at an acceptable level. It's not really possible for you to eliminate risk. All you can do is to try and mitigate or to manage it. So you do this by the means of a well-defined and actively employed security program. So number one, you identify the risk. What is this risk? What is this adverse? Uh, what is the adverse thing that I'm looking at? So sorry about that. So what's the I need to identify the risk. Risk identification. You identify the source of that risk, you identify the cause, you identify what is the consequence and other details of the internal and external risks affecting the security of the organization. So that's what you know. Okay, what's the source, what's the cause, and what's the consequence. Then assessment. You are assess the organization's risk and provide an estimate of the likelihood and impact of that risk. What is the likelihood that that risk will become uh, successful or will become a reality? Let me put it that way. What's the likelihood? Okay. Then what will be the impact? That's a risk assessment. We are trying to say, okay, this risk, what is the likelihood that it will occur and what can be the impact? Then we talk about risk treatment. You select and implement appropriate controls for the identified risk. We have identified the risk, we have assessed it. Then, if this risk happens, how do we uh, what is the control measure that we have in place? Then risk tracking. You will ensure appropriate controls are implemented to handle known risks and calculate the chances of a new risk occurring. You track it by making sure that those controls that you put in place during the risk treatment, um, they are implemented to handle the known risks and to calculate the chances of a new risk occurring. So then we do risk review. You evaluate the performance of the implemented risk management strategies. So the risk management practices, what how have they been doing? Have they been able to reduce or to manage the risk? So very very key when we are dealing with risk management. So we identify what is the source, what is the cause, we assess it, this risk, what is the likelihood and what is the impact, we treat it, we put controls in place, then uh, we ensure that the controls that are put in place are implemented. Then we review, you evaluate the performance of the implemented risk management strategies. Now we'll be moving on to cyber threat intelligence. So cyber threat intelligence is the collection analysis of information about threats and adversaries and the drawing of patterns that provide the ability to make knowledgeable decisions for preparedness, prevention, and response actions against various cyber attacks. So basically, it's just what security organizations do, especially like in Nigeria. We have the Department of State Services. What they go is to look at, and in different local governments, they are in every local government in all over the country. I think in the United States, CIA, I think, is more external. I hope I'm correct. While FBI is more internal. So all they do is to collect intelligence to know, okay, what are the threats that are out there. All of the security agencies, whether in Nigeria or in the United States, they know where the criminals are. That's why, especially in Nigeria, when something happens, you see that there are some particular spots where the security agencies go to, because they know where the threats are, where they're emanating from, we know where the adversaries are. So the essence of this, and they supply these reports even to organizations, to state governments. So another story whether the government officials now take this intelligence report seriously. So we also have that in the cyber security world. We have the cyber threat intelligence that allows you to know what are the threats, what are the threat actors, the adversaries, the patterns they are using, and to be able to make intelligible decisions, to be able to be prepared, to know, okay, these are the things to put in place and all that. So we have different types of okay, threat intelligence helps the organization to identify and mitigate various business risks. You identify and mitigate. So we have high level information. Yeah, types of threat intelligence. It can be strategic, it can be tactical, it can be operational, technical. So we have strategic is high level on changing risk consumed by high level executives and management. Tactical information attackers, threats, tactics, sorry, uh, and procedures. And this is consumed by tactics, techniques, and procedures of attackers. So it's consumed by IT service and there's security operations center managers and administrators. We have operational information on specific incoming attack. So this one is specific on is consumed by security managers and network defenders, and technical information on specific indicators of compromise consumed by security operations center staff and incident response teams. Now, threat intelligence, this is the life cycle. Number one, there's planning and direction. Define intelligence requirement, make a collection plan. How are we going to collect the intelligence? Form a team, an intelligence team, send requests for data collection, plan and set requirement for other phases. The first phase is planning and direction. Here we define the requirement, intelligence requirement. Then we'll make a collection plan, we'll form an intelligence team, and okay, we send requests for data collection, we plan and set requirements for other phases. Then number two, we the collection phase. You collect required data that satisfy intelligence goals. You collection sources. These are different collection sources we'll still talk about. We have OSIT, human intelligence, IMIT, MASIT, and different collection sources. They have them. They have who elaborate on that. Let me quickly run. Then processing and exploitation. You process the raw data, the intelligence that was obtained. Then you convert processed data into usable format for data analysis. Number four, you analyze and analysis and production. You combine information from phase three into a single entity. That's what you collected in under processing and exploitation. Then you include facts and findings and forecasts. Analysis should be objective, timely, accurate, actionable. You perform confidence-based analysis. Then number five, which is the final phase, you disseminate and integrate. You deliver the intelligence to the intended consumers at different levels. So you remember, strategic is for high level, tactical is for managers, administrators. Operational is for defenders, network defenders. Technical is for SOC staff. So when we are trying to model a threat. So a threat is anything that has the ability to create an adverse impact on the organization. So threat modeling is a risk assessment approach for analyzing the security of an organization by capturing, organizing, and analyzing all the information that affects the security of an application. You identify, okay, is for analyzing the security of an application by capturing, organizing, and analyzing all the information that affects the security of an application. You capture, you organize, and analyze. So, number one, you how much you need to determine how much effort needs to be put towards subsequent steps. That's identify security objectives, application overview, identify the component data flow and trust boundaries, decompose the application, helps to find more relevant and more detailed threats, identify threats relevant to the control scenario and context using the information obtained in steps 2 and 3. Number five, identify vulnerabilities. Identify weaknesses related to the threats found using vulnerability categories. So that's the threat modeling phase. Now we'll come to incident management. When an incident occurs, how do you manage it? We have been talking about risk, we have been talking about threats. Now the incident has occurred. So how do you manage it? Because we do all that we're supposed to do as an organization to make sure that the risk that we're looking at, it doesn't occur. We we do all we can that so that the threats don't become a reality. But when it becomes reality, what do you do? Then even before becoming reality, you would have prepared your organization to have a way to respond when an incident occurs. How do you respond? How do you respond? Because if you are not ready for when something happens, definitely by the time it happens, everybody will be all over and there will be no guideline on, okay, this is how we respond, this is what to do. So that's why incident management is something we put in place. So incident management is a set of defined process to identify, analyze, prioritize, and resolve security incidents to restore normal service operation as quickly as possible and prevent future occurrence or recurrence, of the incident. So what you do is to identify this incident has happened. Then you analyze, okay, what happened? Then you prioritize, okay, what is the first thing? The most important thing when an incident occurs is how do we come back? How do we make sure that our system is restored and working the way it ought to occur? So you prioritize and resolve security incidents in order to restore normal service operations as quickly as possible. Not only that, and to prevent future recurrence. So, and you have to learn from that incident in order to do that. So you incident management involves vulnerability handling. That vulnerability, how do we handle it? How do we handle it? How do we handle it? We have seen the a weakness was exploited. How do we undo that weakness and close up that vulnerability? Artifact handling, announcements. Of course, you need to inform people. Oh, this has happened many times when all these big organizations, Yahoo, LinkedIn. I think did it happen to Facebook? I'm not sure. I can't remember, but I know for LinkedIn and Yahoo, it happened to them. The first thing is to make announcement. Oh, we have suffered this, but most times the announcement they make is half much long after. This real life, I'm telling you, they do it much long after. The thing may have even happened some time ago, and most times even they even wait until that issue may have even been leaked by somebody. Somebody may have just leaked the information or something happened. Most times they don't want to give announcement because of course when you're announcing that you have been attacked or your system has been breached, you know that it may lead to loss of confidence on the part of your clients or investors or other people that are involved, or business reputation, loss of business reputation. Of course, you will not be too keen on that. Then we have alerts, we have incident handling, triage, reporting and detection, incident response analysis, other incident management services. So very, very. So artificial intelligence and machine learning. Sorry, let me just quickly. Okay. Incident handling and response. Number one, you prepare. Number two, there's incident recording assignment, incident triage. There's analysis of the incident. You is categorized it by is prioritized. So the I incident handling and response team further analyzes the compromised device to find incident details such as type of attack, its severity, target, impact, and method. So in under notification, the various stakeholders are informed. The management is informed. Containment, you don't want it to spread to the organizational assets. That's containment. Evidence gathering, you gather evidence. Forensics, of course, you want to know what happened. um, Method of attack, you want to know the vulnerability exploited, you want to know the security mechanisms about the network devices infected and applications compromised. So eradication, you want to remove or eliminate the root cause of the incident. Then you want to recover, of course. You want to restore the affected system, the services that have been affected, and you want to also do recovery. That's when you now look at your backups and also restore files that may have been lost, or software applications to restore them from the backup. Other post-incident activities, documentation, impact assessment, and all that and all that. So machine learning and artificial intelligence also has a role. They are now being used a lot. I was reading a document yesterday talking about the role of chat gpt in what's it called, in cyber security. So they are now used vast in various industries and applications due to the increase in computing power, data collection and storage capabilities. So it's being used a lot. Let me quickly move on. We have just few minutes. Okay, what are the roles of artificial intelligence and machine learning to prevent cyber attacks? It can be used for password protection and authentication, phishing detection. Like phishing is an attack. So in order to dictate, there would have been parameters that would have been set on the AI or the ML to prevent. So what a human may not be able to easily identify. If you look at a phishing email, can you easily identify that this email is a phishing email? The attackers are now becoming more crafty, or they are becoming craftier, so to speak, in setting up these phishing emails. Can you easily identify it? But if you have an AI system that is put in place, it looks very closely, and of course it will be able to identify it faster and even better than a human can do. Then we have threat detection. Threat detection, you can detect, it can be used to detect threats, it can be used to manage vulnerabilities, it can be used to do behavioral analytics. You know that we'll talk more about that later. But when you talk about intrusion detection system and intrusion prevention system, intrusion detection system deals more with signatures, while intrusion prevention system deals more with behavior. It looks at patterns of traffic. and looks okay, this traffic, this is the way it ought to go. But if there's a change in that pattern, then that's like a behavioral analytics. So, but it may not be easy for a human being to be able to easily decipher that, to be able to know that. But it's much easier for artificial intelligence and machine learning to be able to do that. Network security, AI based antivirus. So artificial intelligence based antivirus, fraud detection, botnet detection, AI to combat AI threats. So, okay. Any question? So we're wrapping up today's class with talking about the different standards that we have, the security standard, the payment card industry data security. So any organization that is processing payments information, um, that or that any services that stores or processes payment cards or information on payment cards must abide by this particular security standard. So the payment card industry data security standard is a proprietary information security standard for organizations that handle card holder information for major debit, credit, prepaid, e-POS, ATM, and POS cards. So PCI DSS applies to all entities involved in payment card processing, including merchants, processors, acquirers, issuers, and service providers, as well as all other entities that store, process, or transmit cardholder data. So there's a particular standard that they must abide by. So anyone that processes cardholder information, that stores it, they must abide by a particular standard. This standard is the PCI DSS, Payment Card Industry Data Security Standard. So they must build and maintain a secure network. They must protect cardholder data. They must maintain a vulnerability management program. They must implement strong access control measures. They must regularly monitor and test networks. They must maintain an information security policy. So if they fail to meet these requirements, it may result in fines or termination of payment card processing privileges. So all these things must be in place. So when we talk about building and maintaining a secure network for people that are in the payment card industry, they must install and maintain a firewall configuration to protect card holder data. There must be a firewall. So the the attackers cannot just gain access into their network or into their servers like that. There will be a firewall. A firewall is just a protection against attacks. Just as is name it, firewall. So it doesn't allow egress and a certain predefined egress and ingress traffic. When we talk of egress, we are talking of traffic that is coming from within the network to outside. When we are talking of ingress, we are talking of traffic that is coming from outside the network into the network. So there are some predefined egress and ingress traffic that it does not allow. So that's the work of a firewall. So do not use vendor supplied defaults for system password. We'll talk about this. It's like a very simple uh, mitigation or countermeasure, but very important. Very important. Don't use vendor supplied defaults. There are websites where you can easily just gain see all those default passwords. So if you use it, that that is a gunner, is a gunner. So protect cardholder data, protect stored cardholder data, encrypt transmission of cardholder data across open public networks. So there's encryption whenever the cardholder data is being transmitted, is encrypted. So it's not being transmitted in clear text. Maintain a vulnerability management program, use and regularly update antivirus software programs, develop and maintain secure systems and applications, implement strong access control measures, restrict access to card or data by business need to know, assign a unique ID to each person with computer access, restrict physical access to card or data, regularly monitor and test network, track and monitor access to network resources and card or data, regularly test security systems and processes, maintain a policy that addresses information security for all personnel. So there must be awareness for all personnel. They must know that we have other standards and policies. We have the ISO 27001 2013. This is it specifies the requirement for establishing, implementing, maintaining, and continually improving an information security management system within the context of the organization. So these are very tough requirements that some organizations have to meet up with. Um, there are different organizations, and if you are to be taken seriously, you have to try and meet up with these requirements. And it's intended to be suitable for several different type of use. So it's used for the following: use within organizations to formulate security requirements and objectives, used within an organization to ensure security risks are cost effectively managed, used within organizations to ensure compliance with laws and regulations, definition of new information security management processes, identification and clarification of existing information security management processes, used by organization management to determine the status of information security management activities, implementation of business enabling information security, used by organization to provide relevant information about information security to customers. So the ISO 270 has a lot. I mean, has some specific standards. It has some specific standards that um, uh, it expects an organization to abide by. So it has specific requirements. It has specific requirements, and if an organization is able to meet up with this, then it's rated high. It's rated high. Um, it's rated high. So then we also have some acts like health insurance portability and accountability is basically in the US, is in the United States. This health insurance portability and accountability act basically is to protect patient data, because when you visit the hospital, your data is taken, your name, your history, the treatment, and all manner of personal information that you don't want everybody having access to. Some of us even don't share our medical information even with our relatives, not to talk of now having it be something that everybody has access to. So it's very private. So this uh EPA, we call it Health Insurance Portability and Accountability Act. So it requires every provider who does business electronically to use the same healthcare transactions, code sets, and identifiers. The privacy rule, it provides further protection for personal health information. So personal health information is provided federally. This is in the US, like I said, is held by covered entity and gives patients an array of rights. So patients have rights with respect to their information. Security rule specifies a series of administrative, physical, technical safeguards for covered entities to use to ensure confidentiality, integrity, and availability of electronically protected health information, and so on and so forth. We also have different acts. We have the Sarbanes-Oxley Act. So basically, all these acts and all these like the EPA and this, they are, it depends on where you are operating as a cybersecurity personnel. if you're operating in a particular environment, you need to know. Just like in Nigeria, we have our National Data Protection Bureau, and there's a Data Protection Act in Nigeria. So if you're operating in Nigeria, you need to be conversant with that. So wherever you're operating, if you're operating in Europe, you need to be conversant with GDPR. So you need to be conversant with GDPR and all that. So then we have the Digital Millennium Copyright Act and Federal Information Security Act. Digital Millennium Copyright Act, sorry. It's a United States copyright law that implements two 1996 treaties of the World Intellectual Property Organization. So it defines legal prohibitions against circumvention of technological protection measures employed by copyright owners. Then we have the Federal Information Security Management Act. All these acts are there. So this is the one I was referring to. General Data Protection Regulation. This is mostly in Europe. Was put in effect in 2018. One of the most stringent privacy and security laws, and this is what put I think Google and Facebook in trouble in Europe some years ago. So whenever they violate that act, they are always fined. So it will levy harsh fines against those who violate its privacy and security standard, with penalties reaching tens of millions of euros. So GDPR, General Data Protection Regulation. Data Protection Act, this for the UK. In 2018, they have their own local. The GDPR covers the entire Europe. The Data Protection Act covers the UK. So we have different cyber law in different countries. In the US, we have different laws. We have different laws. In Australia, we have different laws different cyber laws. United Kingdom, we have different laws in China. Copyright law, India, Germany, Japan, South Africa. Nigeria too has, it's not here, but Nigeria has its own law. That is that Data Protection Act. But I can't remember the year. Maybe that it was it 2021 or 2022. It's quite recent, and the bureau itself is recent. So in this module, we discuss elements of information security. We discussed about information security attacks. We talked about information warfare, defensive and offensive. We talked about information security attacks. We have insider. We have distribution attacks. We have close and all that. Then we have hacking concepts. We have hacker classes, black hats, suicide hackers, activists. We talked about scope and limitation of ethical hacking. We talked about information security controls, cyber threats, risk management, cyber threat intelligence, threat modeling, incident management processes. We talked about information security acts and laws. So that covers our first module. Any questions?
I have a question.
Okay, go ahead.
Yeah, can we see AI is a danger to a democratic society?
AI
Yeah.
has been a danger to a democratic society.
If AI can be a danger to a democratic society.
Well, can it be it's not only a democratic society, it can be a danger to any society, whether democratic or this. The issue is this: anything can be a danger. It depends on the person that is using it. You understand? So, but with the way the AI is, a lot of things, the capabilities and all that, of course, it can be a danger anyway. I hope I've been able to at least scratch that question, Mr. Isaac. Mr. Isaac, or do you want me to still say more about that?
No, yes, it's fine. I understand.
Okay, okay. So it depends on the person handling it. Any other question, or do you have a contribution or one thing you want to us to work on before we end the class for today? We'll let you, we'll inform you about the next class. It will be next weekend. So you'll be informed via email.
Yes. What's the schedule of the class? Is this supposed to be Friday, Saturday, Sunday?
Yes, it's Friday, Saturday, Sunday. So, but yes, Friday, Saturday, Sunday. So, by tomorrow we'll send out the schedule for next weekend, or for this weekend. Sorry, this weekend, because we're already in a new week today.
Yes.
So you'll be informed.
On that note, I
Mr.
think
Kevin.
yes. On that note of Friday, Saturday, Sunday, I personally may have an issue with the Friday because
Okay, you
my
prefer
schedule.
Saturday and Sunday.
Yes.
Okay.
No,
Okay.
Mr. Kelvin. You, as long as the class is recorded for Friday, you can always have access to that. That's not an issue. You might
No, I'm
not be
just saying it from my
Okay.
own
Yes,
perspective. What
that's
about if I
that's.
have a question? I'm just saying from my perspective. I don't know
Oh,
how the schedule.
yeah. If you have a question after listening to the class, you can make for any live class you're able to join. You can always take us back. It's not an
Mm,
issue.
No problem. Thank you.
All right. Thank you. Thank you for being part of today's class. So you'll be informed. I think by Friday we'll be here. Thank you. Stay safe.
Thank you so much.
Regards to your family.
You as well, sir. Yes, sir. Thank you, sir.
Thank you, sir.